Hello students. So let's continue with our NCERT chapter 7, that is alcohol, phenols and ethers. And today is a theory part 8. So this is the disclaimer. Now, what is the objective of today's lecture? So after attending this lecture, you'll be able to understand the topics which we are going to cover today. So today we will discuss the chemical reactions of alcohols and phenols on the basis of their functional group. So for your reference, I have also mapped the NCERT sections which we are going to cover today. So today we are going to cover section 7.4.4, that is chemical reactions. And for your better understanding of the concept, we will solve a NCERT exercise question, that is 7.19. Okay, so let's begin with today's lecture. So when we were discussing about alcohols, I told you that alcohol can behave as both nucleophile also as well as an electrophile also. So when alcohols behave as your nucleophile, there is a cleavage of OH bond. And when alcohol is behaving as an electrophile, then there is cleavage of carbon-oxygen bond, that is CO bond. Now, electrophile means that love electrons. So, when we talk about the cleavage of CO bond, your alcohols behave as an electrophile. So, if we are talking about the reactions which are involving the cleavage of CO bond, so we see the reactions for alcohols only and not for phenols. So, can you guess why the reactions which involve the cleavage of carbon-oxygen bond is only for the alcohols and not for phenols? See, the reason is very simple. If you look towards the structure of phenol, you all know that in phenol there is an aromatic ring and your OH group is directly attached to that ring. So in phenols we all know that oxygen has electron density to donate. So that is why there is resonating structures in phenol. So when you will look towards the resonating structures of phenol, you will see that the carbon-oxygen bond develops a partial double bond character. So because the carbon-oxygen bond develops a partial double bond character, so that double bond is difficult to break because double bond is more stronger than a single bond and even more stable than a single bond. Okay, so that is why for the cleavage of carbon-oxygen bond, the reactions are primarily seen for alcohols and not for phenols, because phenols develop a partial double bond character between carbon and oxygen. So first reaction that we will see is reaction with hydrogen halides. Halides that can be fluorine, chlorine, bromine or iodine. Okay, so let's see the reaction. So when your alcohols reacts with hydrogen halides, halides like I told you, it can be chlorine, bromine or iodine. So they form alkyl halides and water. That is alcohols plus HX, they give you alkyl halides and water. Now this reaction follows a nucleophilic substitution path. Now look at this reaction. Here you can see alcohol, that is ROH, and here you can see hydrogen halide. Okay, this is when you react alcohol with hydrogen halide, you get alkyl halide. Okay, and water is being released in this. Now this alkyl halide can be anything, it can be chlorine, bromine or iodine. So when alcohol has to react with hydrogen halide to form alkyl halide, there is breakage of carbon-oxygen bond. Look here, this R is any carbon group which is attached. It can be any alkyl group or aryl group. So if this R is over here, this is the bond between carbon and oxygen. And when you will see the alkyl halide is formed, this bond between carbon and oxygen is broken. Okay, here it is the bond between R and X. So this is, you will see there is cleavage of carbon and oxygen bond. So whenever we have to make alcohol as an electrophile, we study, first we will protonate the alcohol. So when we will protonate the alcohol, our OH2 group will leave and a carbocation will be formed. And once the carbocation will be formed, so our halide, that can be chlorine, bromine or iodine, they will attack on that carbocation, because here your halide will act as a nucleophile. Okay, because it has electrons to donate and carbocation is electron deficient here. So this halide will react, it will attack to your carbocation and you will see it will form alkyl halide. Plus water is being released. So as I told you that in the intermediate step, a carbocation is formed when OH2 group leaves. So the reactivity of alcohols, it depends upon the stability of a corresponding carbocation. So if the stability of the carbocation will be more, the reactivity of alcohol will also be more, because it is depending on the stability of your carbocation. So if I talk about the stability order of carbocation, then we know that tertiary carbocation is more stable. Then comes the secondary carbocation, and at last comes the primary carbocation. Now if I talk about secondary carbocation, then in secondary carbocation we know that here there are 3 R groups, means the carbon is further attached to 3 carbon atoms. That means there are 3 alkyl groups in tertiary carbocation. In secondary, what happens? The carbon is further connected to 2 other carbon atoms. And in primary carbocation, the carbon is connected to further by 1 carbon atom only. So in tertiary carbocation, there are 3 alkyl groups. So 3 alkyl groups are donating the electron density to that carbocation, because that carbocation is, if you look towards that carbocation, it is electron deficient. So in tertiary, what happens? There are 3 alkyl groups that are donating, because alkyl groups are electron donating groups. So they will donate an electron density to that carbon. Since here there are 3 alkyl groups, so it will help you to spread the positive charge, which will make your carbocation more stable. So tertiary carbocation is more stable, and in primary there is only 1 alkyl group which is attached to your carbon. And here there is only 2 alkyl groups. So in tertiary, the positive charge spreads out because of 3 alkyl groups and it makes your carbocation more stable. So this is the stability order for your carbocation. So as I told you, the reason is that plus I effect of alkyl groups, this stabilizes the positive charge on carbocation. And since there are 3 R groups in tertiary, so it will stabilize your positive charge. So if we talk about the order of reactivity, so as I told you that your reactivity of alcohol depends upon the stability of carbocation. So if tertiary carbocation is most stable, then the order of reactivity will be tertiary, then secondary, and at last it will be primary. So tertiary carbocation, we will say it is more stable, so the tertiary reactivity is most. So if I talk about the reactivity of HX, that is if we take different halides, that is iodine, bromine and chlorine, then what we will see that as the HX bond decreases, the leaving ability of X minus increases. Now what happens? That in hydrogen halide, your X has to leave. Look at this reaction. Your HX bond has to break, because this, your X, which is acting as a nucleophile, has to attack on this carbocation. So your hydrogen halide bond needs to get broken. So if this strength between your hydrogen and halide is less, then your halide can easily leave, right? So if the bond strength is decreasing, the leaving ability is increasing. So see here, if I talk about hydrogen and iodine bond, you know that iodine is large in size. Fluorine is smallest in size, then comes chlorine, then bromine and then iodine. That means the size of iodine is large. So if the size of iodine is large, the bond strength of hydrogen and iodine is decreasing because of large size of iodine. So if the bond strength is decreasing, then this iodine can leave easily. Okay. So if we talk about HI, HBr and HCl, then iodine one can leave more easily as compared to bromine and chlorine because the bond strength of iodine is less. So its leaving ability is more. Okay. And ZnCl2 catalyst is used with HCl because of the low reactivity. So here ZnCl2 is acting as a catalyst. Why? Because it is used along with HCl because of its low reactivity. So I hope you understood the reaction with the hydrogen halides. Now let us see the Lucas test. The Lucas test is used to differentiate between primary, secondary and tertiary alcohols. Okay, so if you have to differentiate that which one is primary, which one is secondary, which one is tertiary, we use Lucas test. So it distinguishes between primary, secondary and tertiary alcohols, which is based on the reaction rate. Now Lucas reagent, it includes anhydrous ZnCl2 and concentrated HCl. Okay, so in some multiple choice questions, this is asked that what is Lucas reagent. So you need to remember that Lucas reagent is anhydrous ZnCl2 and your concentrated hydrochloric acid. Now your primary, secondary and tertiary alcohols, they both react differently with this Lucas reagent. Because they react differently with this Lucas reagent, so that is why it can distinguish between your primary, secondary and tertiary alcohol. So first let us see the reaction with Lucas reagent with tertiary alcohols. So tertiary alcohols, so what happens? Your alcohols, they are soluble in water. Okay, we studied it that alcohols, it contains the OH group. So because of that hydroxyl group, it forms the hydrogen bonding. So we know that the alcohols are soluble in water, but their halides, they are immiscible. That is, they are not soluble in water. Okay, so your alcohols are soluble in Lucas reagent, but their halides, they are immiscible. So if I talk about tertiary alcohols, then tertiary alcohols, they react immediately, forming a turbid solution because of the formation of immiscible alkyl halides. I told you that the alkyl halides of these alcohols, they are not soluble in this Lucas reagent. Okay, so what happens when you react this tertiary alcohol with the Lucas reagent, then they will react immediately and they will form a turbid solution. Turbid solution means, like if I say if you add sugar to the water, then sugar will completely dissolve into that water. But when I say add mud to the water, so when you will dissolve mud to the water, you will see the solution becomes opaque. Opaque means you can't see through that solution. So that is a turbid solution is formed. So turbid solution is formed when something which is immiscible in that given solvent. So your tertiary alcohols, they react immediately and they form the turbid solution. Why? Because of your immiscible alkyl halides. So see, this is tertiary alcohol. This carbon is further connected to 3 other carbons. And when you react it with Lucas reagent, it will react immediately. So the reaction is fast. So it is forming, see here, alkyl halide group is being attached. This alcohol group is replaced by this halide group. And this alkyl halide, it is immiscible. So that is why it is forming a turbid solution. Now if I talk about secondary alcohols, then your secondary alcohols react slowly, more slowly, and to form a turbid solution after few minutes. So tertiary alcohols, it was reacting immediately and it was forming a turbid solution. But your secondary alcohols will react slowly and the turbid solution will be formed after few minutes. So this is a secondary alcohol. See, the carbon to which your OH group is attached is further connected to 2 other carbons. So this is a secondary alcohol. And when it reacts with Lucas reagent, because of the immiscible alkyl halide that is formed, so it will show turbidity, but turbidity will be shown after few minutes, not immediately. And if I talk about primary alcohols, then these primary alcohols do not react at room temperature. So you will see, if you react your primary alcohol with Lucas reagent, you will see it will not give any product. So no product is formed at room temperature. Okay, so you need to remember that your alcohols, they are soluble in Lucas reagent, but their halides, they are immiscible. Because their halides are immiscible, they show turbid solution. So tertiary one react immediately, secondary one it show turbidity but after a few minutes, and the primary alcohols do not react at room temperature. Now let us see the reaction with phosphorus trihalides. So what happens is this reaction that it converts the hydroxyl group, that is OH group, to X via a nucleophilic substitution. And here a byproduct is formed in this reaction. The byproduct that is formed is phosphorus acid, that is H3PO3. So when the reaction happens, it is formed as a byproduct. Now look at this reaction. This is an alcohol. So I told you this alcohol, this OH group is replaced by Br group over here. Okay. So what will happen in this reaction? Since it involves the cleavage or carbon oxygen bond, so here you will see that this carbon and oxygen bond gets broken, and here you will see a carbon and a halide bond is formed. Okay, so since here your alcohol is acting as your electrophile, so first we have to make this alcohol as an electrophile. When I will make this alcohol as an electrophile, then only what will happen, your nucleophile will attack to this alcohol. So how will I make this alcohol as a electrophile? I will protonate this alcohol. So when I will protonate this alcohol, it will become OH2 plus. Okay, so when it will become OH2 plus, what will happen? Oxygen will not tolerate the positive charge. So this, it will leave, the water will leave from here, and on this carbon there will be a positive charge. So carbocation will be formed. Now what will happen when this carbon is electron deficient? It has a positive charge, so some nucleophile has to come to rescue this carbon. So what will happen? Who will behave here as a nucleophile? Your bromine will behave here as a nucleophile. So your bromine will attack on this carbon and this Br groups get attached over here. Okay, so your OH2 group will leave and your bromine group will attach to this carbon. And you can see here H3PO3, that is phosphorus acid, is formed as a byproduct. Okay, see here, because here are 3 hydrogen and 3 oxygen group, because see it is 3 over here in front of ethanol. Okay, so 3 hydrogen groups and 3 oxygen and 1 P. So it will form H3PO3 as your byproduct. So if I talk about the reactivity of alcohol, then again 3 degree, then 2 degree and 1 degree. So 3rd degree alcohol is more stable, because here again the stability of alcohol is depending upon the stability of your carbocation, because when this OH2 will leave, a carbocation will be formed. So your reactivity of alcohol is depending upon the stability of carbocation, and we know that we discussed that tertiary carbocation is more stable, then comes the secondary, and primary one is the least stable, because in tertiary there are 3 alkyl groups. So 3 alkyl groups, they are donating its electron density to that carbon, because there are electron donating groups. So these 3 alkyl groups, it will help you to spread the positive charge, which will make your carbocation more stable. So your tertiary carbocation will be more stable. So because of that, your order of reactivity will be 3 degree, 2 degree and that at last 1 degree. And the reason for this stability is plus I effect of alkyl group. So whenever your alcohols will react with phosphorus trihalides, your carbon-oxygen bond will be broken and your alkyl halide will be formed. See here what is forming? 1 bromoethane. Okay, because to 1 carbon, this Br group is attached and there are 2 carbon atoms. So the root word is ethane. So one bromoethane, that is alkyl halide, is formed. So this carbon and oxygen bond is broken and carbon and halide bond is forming. And H3PO3 comes as a byproduct. Okay, so this is the reaction with your phosphorus trihalides. Now let us see the dehydration of alcohols. Now what do I mean by dehydration of alcohols? Dehydration, you must have listened this word. Then when there is a deficiency of water in your body, we can say that you are dehydrated. So it is advised to drink more and more water to avoid getting dehydrated. So if I talk about dehydration of alcohols, then that means there is removal of water from the reaction. So let us see the reaction. So what happens? There is formation of alkene by elimination of water molecule. So because it is dehydration, so water molecule is removed and alkene has been formed in dehydration of alcohols. Now the reagents which here used is concentrated H2SO4, or you can use H3PO4 or heated Al2O3. So these are the reagents that are being used here. Now the ease of dehydration of alcohol follows the order that tertiary, secondary and primary. Means if there are tertiary, secondary and primary alcohols, then at what ease there is dehydration of alcohols. So in tertiary there is more ease of dehydration of alcohols as compared to secondary and primary. Again, why? Because tertiary one, there is stability of carbocation. So if I talk about the stability of carbocation, then you know that tertiary carbocation is more stable. Then comes the secondary and then comes the primary. Because this tertiary carbocation is more stable, so your tertiary alcohol will form at a faster rate. Because if it is stable, so if it is stable, it is formed more and more and at faster rate. That is why your ease of dehydration for tertiary alcohol is most and for primary it is least. Because primary carbocation is not stable as compared to the tertiary carbocation. Now, what will happen that if we are taking the example of ethanol, then ethanol, it will undergo dehydration by heating it with concentrated H2SO4. Now look here we are using concentrated H2SO4 and look at the temperature. Temperature is high, that is 443 Kelvin. Okay, so harsh conditions are used here. So as I told, in dehydration of alcohol, the water will be removed and an alkene will be formed. Okay, now we will look at the reaction mechanism, that what is happening, how from alcohol the alkene is forming and water is being released. So let us see the mechanism of dehydration of alcohols. Before looking towards the mechanism, your secondary and your tertiary alcohols, they are dehydrated under milder conditions. As you have seen in primary alcohols, it was concentrated H2SO4 and the temperature was high. But when we talk about secondary and tertiary alcohols, then in secondary and tertiary alcohols, what happens? They take place at the milder conditions. So if you see, 100% concentration of acid is not required in secondary and tertiary alcohol. Even 85% concentrated can work here. Okay, so here if you are taking a secondary alcohol, see this carbon is further connected to other two carbons to which your OH group is attached. So this is a secondary carbon, that is propane 2-ol, because to your second carbon your OH group is attached. So here you are taking 85% concentrated H3PO4. You do not require 100% concentrated acid. And the temperature is less when we saw it for primary alcohols. And see, from this alcohols, your propene is formed. Okay. And water is being released. And if we look about this tertiary alcohol, look, the carbon to which your OH group is attached is further connected by other 3 carbon atoms. So this is 2-methyl propane 2-ol. To this second carbon, 1 methyl group is attached. Okay, and to this second carbon, your OH group is attached. So 2-methyl propane 2-ol. Now here only 20% concentration of the acid is required. That is 20% H3PO4. So see, the conditions are milder over here. Okay, you do not require 100% concentration of the acid. And see the temperature. The temperature is 358 Kelvin over here. The temperature is less over here. So when you will see that this alcohol is removed, that H2O is released, water is formed in this, and it forms an alkene. Alkene is formed in this reaction because it is dehydration. So water is removed and you will see alkene is formed. So now we will see the mechanism, how this is taking place. So step 1 is the formation of protonated alcohol. So first we will form the protonated alcohol. So see here, you have OH group here. First, what will happen? I will protonate this alcohol. This H plus is electrophile. It is electron deficient, your proton, and oxygen has electron density to donate. So if it wants to accept and this want to donate. So what will happen? This oxygen will donate your electron density to this H plus. And your alcohol, it will form a protonated alcohol. See, this is a protonated alcohol. There is positive charge on this oxygen. Okay, so what will happen? In first step, you will form a protonated alcohol. And this reaction is fast. Okay, the speed of this reaction is fast. Now the step 2, what happens? There is formation of carbocation. Okay, in step 2, a carbocation is formed. Now there is plus charge on this oxygen. So oxygen doesn't like the plus charge on itself. So this water group will leave from here. That is, this H2O will leave and a carbocation is being formed. See, this carbon has a positive charge. Okay, so a carbocation is formed over here. Now this step is slow step. So if this step is a slow step, then this step is a rate determining step. Okay, because this step is a slow step, so this is rate determining step. So the formation of a carbocation here is the rate determining step. Okay, remember this, that this step of the formation of carbocation is a slow step and it is the rate determining step. So step 1, we protonated. Then step 2, a carbocation was formed. In step 3 now, there is elimination of proton. Now, this proton is over here. Okay, so what will happen? This proton and this hydrogen. So one proton will be eliminated. That hydrogen from here and proton from here. So H plus will leave from here. So you will see and alkene ethene is formed. Okay. Now, if you want to understand in simple words for writing the product, see here. To this carbon, your OH2 group was attached. That is, carbon and oxygen bond was attached here. And here a carbon is attached with this hydrogen. So in dehydration of alcohols, your carbon oxygen bond and your carbon hydrogen bond is broken. Okay, in this carbon your carbon oxygen bond and in this carbon your carbon hydrogen bond is broken. Now what will happen? Oxygen has gone here, so carbon is left alone. Here also hydrogen is gone, so this carbon is left alone. So now what these two carbon will say to themselves? Look at the arrows on the screen. I said that here the OH2 group was attached. Okay, so in this the carbon oxygen bond is broken and here the carbon hydrogen bond is broken. So here oxygen has left and here hydrogen has left. So now this carbon is also alone and this carbon is also alone. So now what these two carbon will say? That let's be friends. Okay, so these carbon will generate a double bond. Okay, so a ethene will be formed in dehydration of alcohols. From your alcohols, alkene is formed. So in step number 3, there is elimination of proton. That hydrogen from this carbon and this charge from here, it leaves as H plus. See, it is leaving as H plus and your alkene is formed. Okay, so whenever there is dehydration of alcohols, your carbon oxygen bond and your carbon hydrogen bond is broken. So an alkene will be formed. The carbon will generate a double bond. Okay, so this was how dehydration of alcohols takes place. And whenever it is formed, to ask which alkene is formed, most stable alkene is preferred. Okay, since here it was an example of ethanol, when there will be a longer carbon chain, so it is always preferred to go by mechanism. If you have to write the answer, do not directly jump to the answer, go by mechanism. Okay, so when you will go by mechanism, you will see that which alkene is more stable. The alkene that is most stable is preferred more. Okay, so this was the dehydration of alcohols. And remember, the formation of carbocation in step 2 is the slow step. Because it is the slow step, that is why that step is RDS. It is the rate determining step. Now, next we will talk oxidation of alcohols. So we will see that what oxidizing agents are used here to oxidize our alcohols to ketones or carboxylic groups. Okay. So alcohol oxidation involves the formation of carbon-oxygen double bond. So whenever there is oxidation of alcohols, you will see the carbon double bond oxygen is formed during this process. And there is breaking of oxygen and hydrogen bond and carbon and hydrogen bonds. Okay, so there is loss of hydrogen molecule. So now look at this. Here you will see that there is breaking of this carbon and hydrogen bond and breaking of oxygen and hydrogen bond. And carbon double bond oxygen is being formed over here. Okay, so it involves the bond breaking of oxygen and hydrogen and carbon and hydrogen. And what will happen? This carbon double bond oxygen is being formed. So now what happens? Your primary alcohol is oxidized to an aldehyde, which is oxidized to carboxylic acid. So first your primary alcohols will be oxidized to aldehyde and that will be further oxidized to carboxylic acid. Okay, now look here, this is your primary alcohol. See, the carbon to which your OH group is attached is further connected by one R group only, that is one carbon atom only. So this is primary alcohol. So when this primary alcohol will oxidize, it will form an aldehyde. See here, CHO group is here. So this is an aldehyde group. Okay, and it is further oxidized to carboxylic group. Look here, the carboxylic group, C double bond OH. This is the carboxylic group. So primary alcohol is oxidized to aldehyde and aldehyde is further oxidized to carboxylic acid. Now, so if there will be a strong oxidizing agent, what do you think it will do? So first let's talk about primary alcohol. Primary alcohol is oxidized to aldehyde. We are using here mild oxidation. That means these oxidizing agents are mild oxidizing agents. So because they are mild oxidizing agents, so primary alcohols will be oxidized to aldehydes. Aldehydes, C double bond OH group. So the mild oxidizing reagents that are used is CrO3 and PCC. Okay, so these two are the mild oxidizing agent which are used over here. And these mild oxidizing agents, they oxidize your alcohols to aldehydes only, not directly to the carboxylic acid. Okay, so here the reagents are CrO3 and PCC. So your PCC is pyridinium chlorochromate. So there is one pyridine, CrO3 and HCl in PCC, that is pyridinium chlorochromate. So your mild oxidizing agent, if this is a primary alcohol and we are using PCC or CrO3 anhydrous, so it will oxidize it to aldehyde. See, aldehyde group is here, CHO group is here. So this is a primary alcohol. See, the carbon to which your OH group is attached is further connected by one carbon atom only. So this is a primary alcohol. It is but2-enol. Okay, because at second carbon there is alkene present, double bond present. So this is 1, 2. So at second carbon, double bond is present. So this is but 2 enol. Okay. And when you are using an oxidizing agent, that is PCC, pyridinium chlorochromate, you will see that it is forming but 2 enol. Enol, it represents aldehyde group, Al. Okay. So this is aldehyde group is forming. So an alcohol over here is oxidizing to aldehyde group. Now what will strong oxidizing agent do? Can you think? Strong oxidizing agent will directly oxidize your primary alcohols to carboxylic acid. Okay. And the strong oxidizing agent is KMNO4. So this KMNO4 is a strong oxidizing agent. So if we are using a strong oxidizing agent like KMNO4 in presence of H+, you will see that this primary alcohol is directly oxidizing to an acid, that is carboxylic acid. So is this clear? Whenever you are using a mild oxidizing agent, it will oxidize your primary alcohols to aldehydes. And the mild oxidizing agents are CrO3 or PCC. But if you are using a strong oxidizing agent like KMNO4, potassium permanganate, then this KMNO4 will oxidize your primary alcohol directly to your acid. Okay, so this is the difference between mild oxidizing agent and strong oxidizing agent. As when we discussed about when we were discussing about that, when you're about the here it is oxidation of alcohol, when we were discussing about the reduction. Okay, then we discussed about NaBH4 and LiLH4. Then there I told you that NaBH4 is a weak reducing agent and LiLH4 is a strong reducing agent. So similarly here, your PCC and CrO3 are mild oxidizing and your KMNO4 is a strong oxidizing agent. So look, this example, this is a ethanol, which is your alcohol group. Okay, this is a primary alcohol because the carbon to which your OH group is attached is further connected by one carbon. So when you are using a strong oxidizing agent like KMNO4, potassium permanganate, you will see it is directly forming an carboxylic acid, ethanoic acid, C double bond OH. This is a carboxylic group attached. So it is directly oxidizing your alcohols to carboxylic acid. So your secondary alcohols are oxidized to corresponding ketones. Your primary alcohols, they are oxidized to aldehydes, and if you are using a strong oxidizing agent, then it is oxidizing to carboxylic acid. But what happens in case of secondary alcohols? They are oxidized to corresponding ketones. Okay, because see here, this is a secondary alcohol because the carbon to which your OH group is attached is further connected to two other carbon atoms. So when you are using CrO3 over here or even KMNO4 over here, it will be oxidized to ketones. Why ketones? Because what happens in oxidation, there is carbon double bond oxygen is formed. And since two R group are present over here, so it will form a ketone only. So whenever you are taking example of a secondary alcohol, the secondary alcohols are oxidized to their corresponding ketones. Okay, look at this example. What will happen in this example? This is propane 2-ol. Okay, this is a secondary alcohol because see, this carbon is further connected to two other carbon atoms. So what will happen when you will oxidize it by using CrO3 or KMNO4? You will see a ketone is formed. C double bond O and two R groups are here. So this is, you can call it as acetone or propane 2 none. Propane 2 on because this is a ketone group. Okay, so remember your secondary alcohols are oxidized to ketones. Now it is saying that tertiary alcohols do not undergo oxidation. It do not undergo oxidation under normal conditions. They require strong oxidizing agent like KMNO4 and very high temperatures. Now, can you tell me why your tertiary alcohols do not undergo oxidation? Because as I told you that in this oxidation of alcohols, there is breakage of carbon and hydrogen bond. Okay, because there is breakage of carbon and hydrogen bond, in your tertiary alcohol, there is no carbon and hydrogen bond. Why? Because the carbon to which your OH group is attached is further connected to 3 other carbons. So the valency of carbon is full now. So this, in tertiary alcohol, the carbon do not has any hydrogen. So if it do not has any hydrogen, so the carbon hydrogen bond will not even break. So that is why in tertiary alcohol they do not undergo oxidation under normal conditions. If you want to still oxidize them, you have to use a strong oxidizing agent like KMnO4, and the temperature should be high, at a very high temperature. So this is a tertiary alcohol. See here, this carbon to which your OH group is attached, there is no hydrogen to this carbon. Okay, so your tertiary alcohols will not show any reaction. It will not show the oxidation. Okay. So is this clear? Oxidation of alcohols? In oxidation of alcohols, there is carbon double bond oxygen is being formed. Now let's talk about dehydrogenation of alcohols. Dehydrogenation means there is loss of dihydrogen molecule from the alcohol. That means H2 is being lost from an alcohol. So alcohol vapors, they are passed over heated copper at 573 Kelvin. So what is the process of dehydrogenation of alcohol? That or alcohol vapors are passed over heated copper, and the temperature here you can see is 573 Kelvin over here. So when this process will happen, your primary alcohol will give you aldehyde. Look at this, this is a primary alcohol. This carbon is further connected by one carbon. So when the vapors of this alcohol, it is passed over heated copper at 573 Kelvin, you will see that this H2O group is lost because this is dehydrogenation of alcohols. So what will happen? This H2 groups leaves, okay, and your aldehyde is formed. That is R, C, H and O. So for primary alcohols, in dehydrogenation of alcohols, aldehyde is formed. When you're talking about secondary alcohol, then in secondary alcohol, ketone is formed. Now look at this. This is a secondary alcohol. When you pass the alcohol vapors of this alcohol over this heated copper at 573 Kelvin, you will see that this H2 will leave. So there will be double bond between carbon and oxygen. And since there are two R groups over here, so this is a ketone is formed in case of secondary alcohols. Okay, so dehydrogenation, there will be loss of hydrogen from alcohol, and your primary alcohol will form aldehyde and your secondary alcohol will form ketone. Now if we move forward, we see that tertiary alcohols, it will not undergo dehydrogenation, dehydration reaction. Why? Because due to the lack of hydrogen on the carbon which is attached to the OH group. As I told, in tertiary, if I talk about tertiary alcohols, then the carbon to which your OH group is attached, there is no hydrogen to that carbon. Okay, because the valency of that carbon is already fulfilled. So that is why your tertiary alcohols undergo dehydration reaction, and tertiary alcohol, it forms the alkene. They undergo the dehydration reaction. Okay, so your tertiary alcohols undergo the dehydration reaction due to the lack of hydrogen on the carbon attached with the OH group. So your tertiary alcohols will form the alkene. So look here, the tertiary alcohol is forming a alkene over here. Now there is one NCERT exercise question 7.19. So you have to write the mechanism of acid dehydration of ethanol to yield ethene. So solve this question and then we will discuss this question. Let us see the solution. You have to write the mechanism of acid dehydration of ethanol to yield ethene. So acid dehydration of ethanol is an elimination reaction. Okay, so H2O molecule get eliminated from ethanol to from ethene. So whenever there is dehydration, your water molecule is removed, and from your alcohol, your alkene is formed. That is ethene. So as we discussed, it proceeds in through 3 steps. So let's discuss first step. In step number 1, there will be protonation of ethanol to form ethyl oxonium ion. So first we have to protonate our alcohol to make it an electrophile. Okay. So you will see this is a ethanol. First we will protonate this ethanol. So when I will protonate this ethanol, what will happen? OHH, that this oxygen will get a positive charge. Okay. So here this hydrogen is an electrophile and this oxygen has electron density to donate. So this oxygen will donate its lone pair to this hydrogen and it will get protonated. So this is step number 2. If we talk about step number 2, then I told you in step number 2, there is formation of a carbocation and that is a rate determining step. So if we see the formation of the carbocation, you will see here that oxygen don't like the positive charge. So this oxygen will leave from here and this carbon will get a positive charge over here and your water is being removed. Okay, so what is happening in the second step? A carbocation is being forming and this step is a rate determining step. Now what will be happen? There will be elimination of a proton to form the ethene. So from this carbon, this hydrogen will go and from this carbon, this positive charge will go. So a proton is being eliminated and you will see a ethene is formed and this H plus is released. So you saw that from alcohol an alkene is formed following the process of dehydration of alcohols. Okay, so is this clear? So whenever you are going to give the answers for the dehydration of alcohols, you have to follow the mechanism, go by mechanism and form the most stable alkene. Okay, now we will summarize whatever we have studied in this lecture. So reactions with hydrogen halides we studied first. In that we saw that the reactivity order of alcohols is 3 degree, 2 degree and 1 degree because a carbocation is formed in this reaction and the tertiary carbocation is more stable compared to secondary and then primary. So because tertiary carbocation is more stable, so the reactivity order of alcohol is tertiary, primary and then secondary. Next, if I told about the HX reactivity order, then for iodine the reactivity order is high. Why? Because the large size of iodine. So hydrogen and iodine bond is weak. So because that bond is weak, the iodine can leave easily. Okay, so that is HI, then HBr and at last HCl. So we discussed about Lucas test. In Lucas test, I told you that it can distinguish between primary, secondary and tertiary alcohol. So tertiary alcohols show immediate turbidity. And the secondary alcohols, it show turbidity in 5 minutes. It takes some time. While your primary alcohols, they do not show any turbidity at room temperature. So this is the Lucas test. And Lucas reagent is ZnCl2 plus concentrated HCl. Next we talk about dehydration of alcohols. In dehydration of alcohols, we will use concentrated H2SO4 or H3PO4. Okay. And the ease of dehydration is 3 degree, 2 degree and 1 degree. Why again? Because tertiary carbocation is most stable. And this dehydration of alcohol follows the Sadzeff rule. And we saw for, if I talking about secondary alcohol and primary alcohol, there are milder conditions. You do not require 100% concentrated acid and the temperature is also less. And always you have to form a stable alkene which will follow the Sadzeff rule. Okay. Next, we talked about oxidation. In that, we talked about mild oxidizing agents and weak oxidizing agents. So, primary alcohol will form aldehydes using mild oxidizing agent like CrO3 or PCC, and your primary alcohols will directly oxidize to carboxylic acid if you are using strong oxidizing agents like KMNO4. And the secondary alcohols are oxidized to ketones, and tertiary alcohols do not show any oxidation. Then we discussed about dehydrogenation, that is the removal of H2 from the alcohol, and it is done with heated copper and temperature is 573 Kelvin. So primary alcohols will form aldehydes, secondary alcohols will form ketones, and tertiary alcohols will form your alkenes. So thank you students. I hope you understood today's concept. Have a nice day.